Okay, this is section 9.6. You'll notice for now we've skipped section 9.5, which is completing the square, which is a process that actually creates the formula that we're going to learn in this section. I will go through an example of that, but I'm not going to require you to complete the square at the moment. All right, so 9.6 quadratic formula. Basically what this is going to do is going to allow us to factor anything, okay? It says formulas are shortcuts for procedures that are repetitive. Okay, there are logical and mathematical principles that allow the formulas to exist. This formula is created from a procedure called completing the square. As I stated, I will not require you to complete the square. However, I will demonstrate the procedure below. All right, so here's a quadratic formula. Okay, it says any quadratic of the form ax squared plus bx plus c equals 0. So everything we've been working with. Okay, where a, b, and c are real numbers, and a is not 0. Okay, so these three coefficients can be anything they want to be. Coefficient's constant. They can be anything they want to be, except for this one cannot be 0. They can all be factored using this formula. Okay, says this formula will allow you to factor any quadratic equation that we have already factored using previous methods, and also any quadratic equation that previous methods could not factor. So, for instance, let's say I had something that looked like this, like 3x squared plus 2x plus 1. Actually, let's make that a 12x. And I asked you, okay, use the AC method, or maybe, what number will multiply together to give me 1. Let's just rewrite it this way. Let's say we had that one, just a very basic x squared plus 12x plus 1. If I ask you, well, what numbers multiply together to give me 1 and add up to give me 12, there are no numbers that do that, okay? So that technique would have failed us in regards to factoring. Now with the quadratic formula, we can actually factor this. We can plug these values in to our formula, the a, b, and c that we would see here. We plug that in our formula, and we get our factored form, okay? So just kind of get into some key ideas here real quick, and then we'll get into some examples. The part that is underneath the radical, okay, it's called b squared minus 4ac. That is referred to as what we call the discriminant, okay? Basically tells us how many solutions we're going to have, okay? So this quantity will tell you how many solutions your quadratic will have. It says if b squared minus 4ac is greater than 0, so that means if this is a positive number, you're going to have two real solutions, okay? Basically meaning that our parabola, if we were to graph it, crosses our x-axis 2 times. If this number here works out to be 0, okay, so if your discriminant b squared minus 4ac equals 0, you're going to get one real solution, which basically tells us that our parabola touches the x-axis 1 time, and that it'll touch at the vertex of the parabola, okay? If this number b squared minus 4ac is less than 0, so if it's negative, you're going to have no real solutions, and that means your parabola does not cross the x-axis. Okay, so that's the discriminant, and if you think about that word, that term, why is it called that? It allows you to discriminate the number of solutions. You have 2, 1, or none. Okay, okay, so I want to go through a process here. It's called completing the square. It's going to show you how factoring is done, and then we'll talk about, how does that get us to a formula eventually. So the way I complete the square, it's a series of steps. I think it's about 6 or 7 steps. First thing you do is you go through, no matter what this number is here, you divide everything by it. So I'm going to divide everything by 2 here. And that gives me x squared plus x minus 6 equals 0. Okay. You then go through and you're going to take this constant and you're going to add it to the other side. So x squared plus x equals 6. Okay. The next thing you're going to do is you're going to take half of that term right there. So it's a 1, so I take half of that. So that would be 1/2. And we're going to square that. It gives me 1/4. You then add 1/4 here, and you add 1/4 there. What this allows you to do on this side here, this turns into now x plus 1/2. It basically turns into x plus whatever that number was before we squared it, quantity squared. And this over here becomes, so it's 6 1/4, so that would be, I'm going to write it as 25/4. Okay. Now, just to kind of prove a point here, this thing here should be the same as that. It's just a different format. If I were to take x plus 1/2 squared and write it this way and FOIL it, x times x gives me x squared. I get 1/2 x when I do those two. Multiply those two, I get another 1/2 x. And then last times last gives me 1/4. That's going to give me x squared plus 1x plus 1/4. So that there is the same as that. So this is identical to this right here. It's just written differently. Now that we have this, we can actually try to solve for x by taking the square root of this side and the square root of that side. Well, if I do that, square root of the left side is going to be x plus 1/2. And the square root of the right-hand side, so square root of 25 is 5, and the square root of 4 is 2. So I can do that. Okay. And when I took the square root, it's a plus or minus. We've talked about that in previous videos. So this would be plus or minus. And now I'll have x equals, now I'll subtract 1/2 from both sides, so negative 1/2 plus or minus 5/2. And that's actually two answers. So it's x equals negative 1/2 plus 5/2, and x equals negative 1/2 minus 5/2. Okay, so it's going to give me, 4 halves there, which is 2. And this one here is going to give me negative 6 halves, which is x equals negative 3. So my two solutions here would be 2 and negative 3. Okay, so that's completing the square. Now, is that the only thing we could have done? No, we could have done other things, and maybe you saw it here at this stage right here. When you divide everything by 2, well, let's think about two numbers I multiply together give me negative 6 and add to give me 1. Well, it'd be x plus 3 and x minus 2. Should have factored that way. And then I have x plus 3 equals 0, and x minus 2 equals 0. X would be negative 3, x would be 2, just like I've got there. Okay, so what I'm trying to get at here is that this completing the square process, you can see it's kind of lengthy. It was a long, nasty process. It deals with fractions and things, square roots of fractions, which right now I don't want to get into because chapter 10 is actually going to teach us how to do a lot of that. So that's why I'm kind of skipping over the completing the square at the moment with you guys. But this long process can be kind of a pain in the butt. So what we want to do is see if there is a shortcut. And the shortcut is what we call the quadratic formula. This thing right here. Okay? This right here is exactly the same thing as what we did here in red, except for it combines all the steps and you really only see the final product. You don't see all the intermediate steps that we did here. Okay? So it really takes you from essentially there straight to here. Okay, by bypassing everything in the middle. So let's just go through. I'm going to write down what the quadratic formula looks like. It's x equals, now it's the opposite of b, plus or minus, and then it's b squared minus 4 times a times c all over 2a. Okay. Now, what we need to do is identify what A, B, and C are. So A is that number right there. So A is 2. B is that number. So B is 2. C is that number. So it's negative 12. Okay, I like to do that to make sure I got the signs correct. Okay. And now it's just plugging those values in. So the opposite of b. So b was 2, so the opposite of that would be negative 2. Plus or minus. Okay. Now b squared. So 2 squared minus 4. A was 2. C is negative 12. All over then 2a. So 2 times 2. And now at this point, it's just relying on our order of operations. Go negative 2 plus or minus. Okay, so this bottom's easy to do. 2 times 2 is 4. Now this here, obviously that's a 4. 2 squared is 4. Minus, okay, so I'm going to multiply this stuff. So I'll have 4 times 2 times negative 12. So order of operations says we got to do that multiplication first. So negative 4 times 2 is negative 8. Negative 8 times negative 12 is, I believe it's 96. Okay, so we get negative 2 plus or minus 4. Now this went to plus 96 all over 2a. Or sorry, not 2a. 2a was 4. Okay. So now we just keep simplifying. Negative 2 plus or minus, so 4 plus 96 is 100. All over 4. And now 100 is a perfect square. So negative 2 plus or minus 10 over 4. And now that takes me to 2 answers. Okay? And this is all x equals, so I'll write negative 10, or sorry, negative 2 plus 10 all over 4. And then around here, I'll write x is equal to negative 2, and it's the minus 10 over 4. So that little symbol right there, plus or minus, means you have 2 operations that need to be done. So negative 2 plus 10 gives me positive 8 over 4. Positive 8 divided by 4 is 2. And then here, negative 2 minus 10 is negative 12 over the 4, and that reduces to negative 3. So we see our values for x. X is equal to negative 3 and 2, which is exactly the same answers that we got by completing the square. And it's the exact same thing we got at this stage when we recognized that we could have factored maybe using the product and sum techniques. So what I want you to see here with this example is, one, the use of the quadratic formula, okay? But then to realize that the quadratic formula is actually like a safety net. If you don't know how to factor something, section 9.1, 9.2, 9.3, 9.4, 9.5, if something doesn't make sense out of that, you don't know how to factor them, you can go to this and it will factor it every single time for you. The only catch, the only cost of that, of using this formula, is obviously the order of operation stuff in here can be tricky, okay? Now, what you can do, and I do suggest this, especially early on, come to Desmos. Okay, if I'm struggling with this stuff, and what I do is, I'm just going to put in the discriminant. So 2 squared minus 4 times 2 times negative 12. Oh, this was a 2. And you see that it gives me that 100 that we needed underneath the radical. Okay, if you want to, you can do it all. You can go negative 2 plus. Now we can't do plus or minus. It doesn't have that capability. We can do this. So put that underneath there. Oops. Negative 2 plus this discriminant, and that all needs to be over that all needs to be over 4, and you can see that it gives us the answer of 2 back. And then all I need to do, if I've got this typed in correctly here, all I need to do is come back here and take that plus sign, wipe it away, make it a minus sign, and now you've got the -3. That's what I would do early on. Okay, if you feel comfortable with the order of operations, you can do that stuff. You should. I mean, we're almost done with Algebra 1, and we've been using order of operations since Chapter 2. But if not, plug straight into this. Okay, and it's going to give you your solutions. Okay. Another way, now I don't want to maybe use this too much, but if we understand how Desmos works, we can go opposite of B, we can go plus, I can type square root, B squared minus 4AC, divide it all by, I gotta make sure everything is divided by this, so we'll go back and put a parenthesis here, and a parenthesis there, and then go 2A, okay. And now I'm just going to say, okay, A, what was A? A was 2. What was B? B was also, was B 2 as well? Yeah, B was 2. And C was -12. And you can see right there, it gives the answer of 2. And then I just need to change that to a negative. Give me my answer of -3. Okay. What I'm going to do is actually, we'll keep this up here for our examples that we're going to do here in a moment, just to check them. So I'll make a positive one, and I'll also make a negative one. And then down here, obviously, I can change my A, B, and C how I see fit. And that will give me my 2 answers. But again, you get into other courses, there's going to be times where you're not allowed to use the calculator. You're going to rely on this technique. Maybe there's even times where they want you to leave it with a radical. And we'll see a couple examples of that here in a little bit. Okay, so I'm just going to do these handful of examples with you. This first one, I just want to do it real quick, seeing if there's another technique. So we see that number 3. Are there 2 numbers that multiply together to give me 3 and add to give me 4? If you think about it, x plus 1 and x plus 3 do that. So x plus 1 would equal 0, or x plus 3 would equal 0. That's going to give me x to be -1, or it'll give me x to be -3. So I've got answers using a technique from previous sections. If I didn't realize that, didn't see that right off the bat, I can use a quadratic formula. Say x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's my formula. Okay. Now if I come back up here to that thing right there, I got to identify what a, b, and c are. So a is that coefficient. So a is 1. B is that coefficient. So b is 4. And c is 3. So now it just plug stuff in. Opposite of b, so be a -4 plus or minus 4 squared minus 4 times a times the c all over 2a. So now it's going to be x equals -4 plus or minus 4 squared is 16 minus, this ends up 4 times 1 times 3 is 12. It's going to be minus 12 all over 2. Okay, so that's going to be -4 plus or minus, so it's going to be root 4 all over 2. And now I get -4. Square root of 4 is 2, so plus or minus 2 all over 2. Okay. A lot of simplification there, a lot of series of steps there, kind of, you know, rewriting that as that, and rewriting that as that, and then rewriting that radical 4 as the 2, okay? Now I've got to do the numerator, so -4. So this thing, should give myself a little bit more room here. Let's, I think I can do this, hold on a second. Okay, so now that I've got this -4 plus or minus 2, that means you have -4 plus 2 over 2, and you have -4 minus 2 over 2. So -4 plus 2 is -2 over 2, which that reduces to -1. -4 minus 2 is -6 all over 2, which that gives you -3. Is that the same answer that we had up here? Okay. If I go back to Desmos, type in A to B1, B was 4, and C was 3. Okay, 1, 4, positive 3. And we get the -1 and -3 as our answers. All right, so let's go to the same one I had earlier. 2x squared plus, okay. We're not going to do that one. We already did that one above. I don't know why I've got it here again, sorry. Let's come down to this one. Okay, 2x squared minus 7x minus 3. I could do the, maybe the AC method. So two numbers that multiply, remember, take 2 times -3 gives me -6. Now, two numbers that multiply together give me -6 and add to give me -7. You can go through them all. -3 and 2, -6 and 1. Those are my factors that all multiply together give me -6, but this one adds up to 5. This one adds up to 1. This one adds up to -1. This one gives me -5. None of them add up to give me -7. So previously, if this would have been a problem that we were given in sections 9.1 through 9.5, we couldn't do it. We'd say no answer. A lot of times they'll call it a prime quadratic equation, meaning that you can't factor it. But now that we have the quadratic formula, we have an approach. We can absolutely do this. We can go x equals the opposite of b plus or minus b squared minus 4ac all over 2a. All right. So now the opposite of b, so again, may make sense to write these down. A is that number there, 2. B is that there, so -7. And C is -3. Make sure you take your plus and minus signs with your coefficients and constants. So the opposite of B would be 7, plus or minus. Now I'll have 7 squared minus 4. A was 2. C is -3. All over 2a, so 2 times 2. Keep simplifying, so this will be 7 plus or minus 7 squared is 49. Now you have a negative and a negative, so it's going to be a positive. Okay, so 4 times 2 is 8, times 3 is 24, so plus 24 all over 4. Okay, so now 49 plus 24 was that 73? So 7 plus or minus root 73 over 4. Okay, now 73 is a prime number, so there are no perfect squares that divide 73. Chapter 10 is we're going to talk about how to do square roots in chapter 10. But what we would do here is that we could do one of two things. We can say our answer is 7 plus root 73 over 4, and 7 minus root 73 over 4. And that's an exact answer because there's no rounding here, there's no decimals, nothing like that. But we talked earlier that this root 73 is a symbol for another number. It's an irrational number. In WebAssign, or not Math Excel, I'm sorry, they're going to ask you to type your answers in and round it to like a certain decimal place. So if I put in 2, -7, and -3 here, okay, we see these values. So that value there, let's go, let's go 7 plus square root of 73. That whole thing over 4. You see that one there is the 7 plus root 73. Okay, this negative 0.381 is that one. Okay, now if I go back over to, and I'll do this in GeoGebra, it's a little bit easier in GeoGebra to graph these. Let's graph 2x squared minus 7x minus 3 and see where we cross the x-axis. Now it's not crossing at whole numbers. If I ask this for the place where it crosses the x-axis, let's go rounding out to like 10 decimal places. You can see that that point right there, rounding, I don't know why it went away from 10 down, there we go. We get the negative 0.38 number, which was the negative, or the minus root 73 one. And then here we get, so B is the 3.8861, which would have been that 7 plus square root 73 over 4. So there's always a graphical connection to these. So you can write, like I said, just pay attention to Math Excel. They might want it to, 2 decimal places, so you'd call it 3.89 because you would round that one up. This one you would say is negative 0.39. Or they might want to go 1 decimal place. They might want to go 3, 4, whatever. Just got to pay attention. So all of these are very similar. And you can see it's a pattern. That's what we talked about at the beginning, that the formulas are for things that are repetitive. Okay. So this one, you just got to remember that just like any other factoring that we have to do, one side has to be 0. So I need to add 7 to both sides. And remember that those are not like terms, so this is going to end up being 2x squared plus 9x plus 7 is equal to 0. Try the AC method again. So 2 times 7 is 14. Think out my factors that give me 14 there, 2 and 7. Okay, so I think this thing will factor using the AC method. So let's just take a quick peek at that. I go 2x squared plus 2x plus 7x plus 7 is equal to 0. Okay, so we'll group these, factor 2x out of the front 2. Leaves me with x plus 1. Take a 7 out of the back 2, so it leaves me x plus 1. Gives me 0, or equals 0. So this is going to be 2x plus 7 and x plus 1. If you remember those rules that we take the stuff out front, that becomes a factor, and then the stuff on the inside of the parentheses becomes my other factor. So now I'll have 2x plus 7 equals 0, and x plus 1 equals 0. So this one's going to give me 2x equals negative 7, and then x equals negative 7 halves. This one here, give me x equals negative 1. So we get those answers, negative 7 halves and negative 1. Okay, so as a technique from before, let's see if the quadratic formula generates the same results. Identify your A value. A is 2. Your B value is 9. C is 7. And now we'll go x equals, I think it's a good thing to, every time you do one of these, especially early on, write your formula down. The more you write it down, the less likely you are to forget it. Opposite of B, negative 9. plus or minus. So I'm just gonna go ahead and square b right away. So b squared would be 9 squared, which is 81, minus in 4 times a times c, all over 2a. 2a would just be 4. All right, so so it's gonna be 81 minus, this ends up being, so 8 times 756. So you get x equals -9 plus or minus 81 minus 56. Okay, is that right? 8? Yeah, 8 times 7, 56. So now 81 minus 56 is 25. Just double check my arithmetic here real quick. 81 minus 4 times 2 times 7. 25. Okay, just making sure. All over 4. So like I said, that's going to go to x equals -9 plus or minus radical 25 all over 4. Okay? The one thing that is nice about this stuff is that when I get this number to be a perfect square, whenever I use the quadratic formula, if that's a perfect square, it automatically tells me that another technique would have worked, like the AC method or the product sum technique, something from 9.1, 9.2, 9.3 would have worked instead of the quadratic formula. It's going to go to -9 plus or minus, so square root of 25 is 5, all over 4 then. So then that gives me two things, -9 plus 5 over 4, -9 minus 5 over 4. So -9 plus 5 gives me -4 over 4, which that gives me my -1. -9 minus 5 gives me -14 over 4. They both have a 2 in it, so it reduces to -7 halves. And there again, you get your -7 halves, -1. This one, very similar to the last one, except for now, instead of just a constant here, it's a variable. But I just going to make that, remember we need to have these in descending order. So we do something like that. My A term is +2. My B term is that number right there, so it's a -1. And my C is -36. So now it's just a matter of plugging into the formula. Opposite of B plus or minus B squared minus 4AC all over 2A. So opposite of B would be 1 plus or minus 1 squared minus 4 times A times C all over 2A, which in this case would just be 4. So it gives me 1 plus or minus. All right, so 1 squared is 1 minus, okay, so what's that going to give me? So that'd be 72, 288. Again, just check my arithmetic. So -4 times 2 times -36, 288. So this is going to be 1 plus 288 all over 4. So it goes to 1 plus or minus radical 289, which is a nice number. If I take the square root of 289, I get 17. So I get 1 plus or minus 17 over 4. So it goes to 1 plus 17 over 4, and then I got 1 minus 17 over 4. So 1 plus 17 would be 18 fourths, which is going to reduce to 9 halves. 1 minus 17 would be negative 16 force, which is going to reduce to negative 4. So those are my two solutions. 9 halves, negative 4. Those are my x values. Let's just double check that real quick. Let's go back up to what we had up here. So A was 2, B negative 1, C negative 36. Okay, even with Desmos here, if you want to see you got your 9 halves, hit flag fraction button, you got the 9 halves, and then you got your negative 4. Last one, at least the last one I've got written here. I might do another one here in a moment. This should be 9x squared when I add x squared to both sides. So 9x squared plus 4x minus 16 equals 0. So A is 9, B is 4, C is negative 16. X equals the opposite of B, so negative 4, plus or minus B squared, so 16, minus 4. A is 9, C is negative 16, all over 2A, so 2A would be 18. All these I've been doing the multiplication and stuff like that in my head. If you want it, use your calculator to your benefit. So I go 16. I'm just gonna do the discriminant. 16 minus 4. Just type it in the exact same way you wrote it. We get 592, so we get negative 4 plus or minus root 592 all over 18. I don't believe 592 is a perfect square. Square root 592. Nope. Okay. So you could leave it this way. There's more simplification that can be done. But we'll talk about that, like I said, in chapter 10, and it'll make more sense on how to do that after that instruction. If we want to, see the exact values here using this device here on Desmos. So A was 9, B was 4, and C was negative 16. So we get those two results, and we round those to whatever decimal place they ask you to. There are times where, let's say we have like x squared plus 4x plus 4 equals 0. And this factors a different way, but let's use quadratic formula just to see a situation. So I go opposite of B, so A is 1, B is 4, C is 4. So opposite of B, be negative 4, plus or minus B squared, so 16, minus 4, A is 1, C is 4, all over 2A, which is just 2. And what happens here, if we start to simplify that radical, we get 16 minus 16 underneath the radical. And that gives me negative 4 plus or minus root 0 all over 2. The square root of 0 is just 0. So we get negative 4 plus or minus 0 over 2. Well, if I take negative 4 and add 0 to it, that is the same thing as taking negative 4 and subtracting 0 from it. So we could have gone that route, or like I said, we negative 4 minus 0 over 2, but they both give me negative 2. And you can write it as negative 2 comma negative 2, but that's usually don't do that because it's redundant. Okay, so we just write it one time. But let's see what that when it's a double answer like that. See what the graph looks like here. So we had x squared plus 4x plus 4. I didn't know what it wanted. X squared plus 4x plus 4. You can see here that you only touch your x-axis one time at that negative 2. Let's go back to our notes previously when I talked about the discriminant. when I said that number right, when the discriminant was equal to 0, when b squared minus 4ac was equal to 0, b squared minus 4ac is equal to 0, you have one solution. Okay, so let's do one more, because we've seen some with two solutions, we've seen some with one solution. Let's write one here that would give me no solution. So I'm gonna go negative x squared minus 3x minus 12. I'm just gonna double check. I think that'll work. Just want to make sure it doesn't cross the x-axis. So negative x squared minus 3x minus 12. And you see that that parabola never crossed the x-axis. Okay, so I want to show you what that means to us. Okay, or how that's interpreted through the algebra. So A is negative 1, B is negative 3, C is negative 12. So we're going to go x is equal to opposite of b, so 3, plus or minus b squared, so 9, minus 4, a is negative 1, c is negative 12, all over 2a. 2 times negative 1 gives me negative 2. Now simplifying my radical here, my radical, call a number under a radical a radicand. If I just go ahead, just to quicken this a little bit, let's use Desmos. Let's just go 9 minus 4 times negative 1 times negative 12. You get negative 39 underneath the radical. Negative 39 all over negative 2. So now here's what happens. Whenever you take a negative of a square, or square root of a negative, like negative 39, see how it says undefined? Any negative number I ever choose, so let's just put a in here. Actually, let's use d. And if I let d be any negative number, you see as I scroll through any of these negative numbers, it always says undefined. And what that tells me, if I ever do this work and I get a negative underneath the radical, I don't need to go any further. Okay, I'll stop here for now until we get to algebra 2. But you would stop there and you would say no real solutions. And the reason is because you cannot take the square root of a negative. Okay, and what it tells us then is that our parabola never touches the x-axis. Some of you have emailed me looking for like further guidance. A couple websites that I think are useful. That's a good website. This is another good website. And you've all probably been to Khan Academy. That's a good website. And you can do a quick, just Google or YouTube search the section title or the key thing that we're talking about, and you will get a series of explanations, series of examples. In addition, email me. Okay, I can assist where necessary.